Here's lesson 2 on relations and functions. Some vocab we need to understand before we can keep going with this is what a relation is, a domain, and a range are. A relation is just a set of ordered pairs. So anything that looks like 3 comma 2 or A comma B. These are sets of ordered pairs. They kind of give us some sort of direction on a Euclidean plane or a graph. The domain of a relation is the set of the first coordinates of the relation. In other words, the x values. So if we were graphing x and y, our x value is the first one, our y value is the second one. So the domain is the set of all the different x values that we see. If we have a bunch of different sets of ordered pairs, we would just take out the first value and put them all into one big set. So right now, the domain of these 3 points that I've put up here, the domain would be the set 3, comma, a, comma, x, all of the first values. The range of a relation is a set of second coordinates of the relation, so the y values. So it would be this, this, and this. So in other words, the range would be the set, again that squiggly bracket, that contains 2, b, and y. So let's take a look at this question here. In the scoring system for some track meets, first place is worth 5 points, second place is worth 3 points, third place is worth 2 points, and fourth place is worth 1 point. This scoring system is a relation, so it can be shown as a set of ordered pairs. So let's take a look at what's going on with these ordered pairs here. The first part is telling me what place the person came in the race. First, second, third, or fourth. The second value is how many points they earned for coming in that place. So they earned 5 points, 3 points, 2 points, and 1 point. So this is one way to show a relation. Now if you notice, in this relation, this is a set. I have the set bracket here and the set bracket here, and within the set are a bunch of points. Notice there's each ordered pair is separated by, has parentheses around it and separated by comma. Within each ordered pair, the two numbers are also separated by a comma. But this isn't the only way that we can show a relation. There's lots of ways we can show them. We can use graphs, tables, and mapping diagrams also. So let's take a look at how we can do that. First, we can look at a table. Well, let's create this table. It says track scoring. Okay, so the first column is going to be the place that someone came in. And if you look as you go through, I have first place, second place, third place, fourth place. We also have the second column is the points they scored. So at first place they scored 5 points, second place 3 points, third place 2 points, and fourth place 1 point. It's the same information that was being given up above in the set notation, except just in a table form. Let's take a look at a graph. So we can graph our data as well. If you notice, we have the place the students came in, the racers came in, going along the bottom. Oops, let's use red here. And we have the points they scored going up. Now whenever we have an axis type, like a graph like this with two axes, this is our x and this is our y. The horizontal is the x, the vertical is the y. And if you look, that's exactly what was going on in our relation up above. The x values are the red ones, that goes across. The green values are the y values, those go up. So let's see. The first one we had was 1, 5. So we look at this and we say, okay, I went over 1 and I went up 5. And that's how I get there. I can also go over 2 and up 3. I could go over 3 and up 2, or I could go over 4 and up 1. So again, this is just another way to represent the same data. And now this final one's kind of a new one. This is called a mapping diagram. And what we can do is we can make kind of two lists. The first list is going to be the place. The second list is going to be the points. In other words, the first list ends up being what we call the domain. It is that set of all those x values, the first numbers. So let me go ahead and write that in here. That first one, this is now the domain. Oh, let me use this red. And the green one, or the points one, is going to be the range. Okay, these were the x values and these were the y values. So it's called a mapping diagram because what we're going to do is we're going to take a value, so from the domain, we always start there in the domain, and we're going to map that value to a value in the range. So the number 1, in this case, maps to 5. The number 2 maps to 3. Number 3 maps to 2. And number 4 maps to 1. Sometimes these arrows go all over the place. They could cross each other and just kind of go all over and they get kind of crazy. But it's kind of a nice way to be able to understand the relation and how different numbers relate to other numbers, how the domain relates to the range. So all of these different things, tables, graphs, mapping diagrams, sets, these are all the same. It's all the same information, just being shown in different ways. So let's look at how we actually determine the domain and range of a relation. Well, take a look at this graph here on the top left. It has the point 1, 2. In other words, it went over 1 and it went up 2. Let me see. So I went over 1, use the pen, over 1 this way, well, over 1 and up 2, so let's use green, up 2. And this point over here was over 3 and up 4. I'm going to try to stay using the red for the domains and the green for the range. So when we talk about domain, we're talking about the set of all x values that this picture or this relation has as part of it. So there's more to this than just those 2 points. There's everything here in between. There's everything between these 2 points along this line. Now I can't be certain exactly where every single one of these points are. So I can write the domain as a compound inequality using the minimum and the maximum of the domain. In other words, let me look and see. As I go from, the domain is a set of x values. So I start at 1 and I keep going over until I get to 3. So this entire graph on the x scale is between 1 and 3, including both 1 and 3. So that sounds a little bit familiar, right? Including 1 and 3. So let's see how this works. Our minimum value is 1. So let's see, the domain. Okay, the minimum value is 1. The maximum value is 3. And I want everything in between. So now I'm going to use inequality symbols to show that 1 is the minimum and 3 is the maximum. How do I do that? Well, if 1 is the minimum, then 1, so x has got to be greater than or equal to 1. It can be equal to 1, and it has to be greater than it because it's the minimum. It can't be anything less than 1. And if 3 is the maximum, then x needs to be less than or equal to 3. It can't be more than 3, but it can equal 3. It just can't be more than 3. So now I've been able to write the domain of this picture here, of this graph, in terms of a compound inequality. And if you remember correctly, this is an AND type of compound inequality. So let's try to take a look at the range now. Remember, the range is the set of all the y values. So now we're not going across. Now we're going to start looking up and down. So let's see. So it goes from 2 to 4. 2 to 4. So this is the range. So it has a minimum of 2 and a maximum of 4. So let's see, the range would have a minimum of 2, a maximum of 4. It's the y value, so I'm going to use y instead of x. And since 2 is the minimum, y must be larger or equal to 2. And since 4 is the maximum, y must be smaller or equal to 4. So in other words, the range is everything from 2 to 4 and everything in between. And that's all there is to domain and range, really. It's the set of all x values that's making up this relation, or the set of all y values that it's making up this relation. So what is a function? Well, a function is a special type of relation, a relation that pairs each domain or input value, the x values, with exactly one range or output value. Okay, so let's take a look at what that means. Let's assume here that this on my mapping diagram is the domain and this is the range. Now, this definition is extremely specific and extremely important. Everything in the domain must match up with exactly one element from the range, exactly one output from the range. Okay, so let's see. This 7 maps to both -1 and 7 maps to 0. So we have something in the domain, that is matching up with 2 things in the range. And it has to match up with exactly one thing in the range. So whatever this relation is here, this is not going to be what we consider a function. Something neat to notice, though, is that all of these numbers, kind of the arrows start to cross. So this is the first time you're seeing where mapping diagrams can actually do that. They will sometimes, the arrows will end up crossing each other and going all over the place, which is kind of neat. Let's take a look at this table now. This field trip table. I have students and I have buses. So for 75 students, this is an x value. It maps to 2 buses. 68 students maps to 2 buses. 125 students maps to 3 buses. If you don't like the way that that's set up, that's fine. You can easily make a different type of connection. We could list these as points. So let's see, I have 75, comma 2. I have 68, comma 2. And I have 125, comma 3. This is another way to write this relationship, this table, where the x values, or the first numbers I wrote, are these are the x values, these are the y values. So the set of all x's, let's see, the domain would be 75, 68, and 125. The range would be 2, and you wouldn't repeat it, so just 2 and 3. So let's see if this is a function. 75, well, let me see. Does every single thing in the domain map to exactly one thing in the range? In other words, here's an x value, 75. Does that map to something? Yes, it does. It maps to number 2. Here is a different number from the domain, 68, and that also maps to exactly one thing, the number 2. Now, it doesn't say anything about those numbers in the range having to be different. Only the things in the domain must map to exactly one thing in the range. 125 also maps something. It maps to number 3. So this is going to be a function. Each domain value is paired up with exactly one range value. Even though that range value is the same for 2 of them, the actual x value does not repeat and map to something different. For example, I don't have 7 mapping to -1 and 7 mapping to 0. The first numbers continuously change over here. And that's where you kind of get this neat little hint here. Okay, we can easily tell if a relation is a function by listing the ordered pairs and seeing if an x value is repeated. Let's take a look at this first one. So we have 1, 2, 2, 3, and 3, 4. Is this a function? Well, the number 1 maps to 2, the number 2 maps to 3, the number 3 maps to 4. So these have all different x values, 1, 2, and 3. So it's going to be a function. How about this one? We have 5, 6, 7, 8, 5, 9, 6, 10. We have the same x values with different y values. So this 5 maps to 6, and then the 5 maps to a 9. So see how the y value is different, but the x value repeats? Whenever that happens, you cannot have a function. It is not considered a function. And that's one easy way to determine whether or not a relation is a function. Alright, I'm going to walk you through some of this, check your understanding. First thing I want to take a look at is we're talking about this circle over here on the coordinate plane. So the first thing we should do is label some of these numbers. So this would be the number 2, this would be positive 2, going this way would be negative 2, going down here would be negative 2, which means this is 4, 4, negative 4, and negative 4. Okay, so what we want to determine is what is the domain of this relation. I don't want to call it a function because that's what we're going to try to figure out. So what is the domain of this relation? In other words, what are the x values that this relation have? Well, let's see. It's between the numbers. What was I using for domain? Red earlier. So let's see. I'll use a darker red. It's from negative 4 to 4. So this whole section is the x values that this picture takes up. Using the green, let's look at the range. The range is the y values, up and down. So from here to here are the y values. So from negative 4 to 4. Okay, so the domain, we can write the domain. like this. It's going to be the set of all x's, and we want it to be between -4, and it can include -4, and these are x values, and go all the way up to 4. So the range, as you might expect, is going to be very similar. It's going to go from -4, and we're using y for the range, and that goes up to 4. Okay, so let's try to create a mapping diagram for this. Let's see what happens when we do that. In the domain, what am I going to have? I'm going to have numbers like -4, -3, -2, -1. So let me just do a couple of them, like -4, -2, 0, 2, and 4. And in the range, we have -4, -2, 0, 2, and 4. Okay. So let's see how this works. When the x value is -4, what is the y value is what we want to look at. So when the x value is -4, we want to try to determine what the y value is. Let's see, hold on. Okay, so when the x value is -4, which is right here, the y value is 0. So this point is -4, 0. So let's map -4 to 0. Alright, when the x value is -2, I end up somewhere up here. That's not going to be a very good one to map. How about when the x value is 0? When the x value is 0, I have this point here. So over 0, down -4. So when this value is 0, it maps to -4. But also, when the x value is 0, we map to the number 4 up there. So, see, this is going to map down here also. And let's see, we're going to skip 2. Let's go with 4. So when the x value is 4 over here, what does that map to? The x value is 4, the y value is 0. So, let's see, so this is going to map like this. 4 maps to 0. Kind of makes a neat little design. Alright, I'm going to get some of these other things out of my domain and range here to avoid confusion. Okay, we just wanted to use points that we could actually see on that graph, and these were the good ones. So, does this uphold the definition of a function? In other words, does everything in the domain map to exactly one item in the range? And that's what you have to ask yourself. Does every item in the domain map to exactly one item in the range? And answer that question in the box over there. So is this a function? Why or why not? So if the answer is yes, explain why. If the answer is no, explain why not. And bring your answer with you tomorrow to class. We will talk about this further. See you then.